Okay, this looks like a command of evidence quantitative. We want to support the claim. Okay, let's take a peek at the graph, see if we understand it. Remember, we're going to have to find an answer that's accurate to the graph and relevant to the claim. We need both. So probability of voting, voters, political orientation, level, political information, probability of voting. Okay. And what's the legend? I've got 2 bars for each sort of orientation, whether you're Democratic, Independent, or Republican. I've got low information and high information voters. Okay, and what's going on here? So as I move from Democrat to Republican, high information voters kind of go down a little bit for independents and then back up again. And low information voters drop precipitously as we go to independence and then go back up again. So if you don't have a lot of information, you don't really tend to go independent, or your probability of voting goes down significantly if you're an independent, low information voter. Whereas you kind of stay high if you're a high information voter. I think that's what's going on here. Probability of voting versus your orientation, whether you're low or high. Okay. So the lowest probability of voting is an independent with low information. Okay. He's most likely not to vote. And on the extremes, high information, most likely to vote. Okay. Let's read the text. I think I have some sense of the graph. Economists Charles and Stevens investigate a variety of factors that influence voter turnout in the United States, using survey data that revealed whether respondents voted in national elections and how knowledgeable they are about politics. Okay, so we have 2 factors here. They claim the likelihood, here's our claim, of voting is driven in part by potential voters' confidence in their assessments of candidates. Essentially, so what does that mean? The more informed voters are about politics. So your likelihood of voting is at least in part driven by your informed level as a voter. Okay. The more confident you are at evaluating candidates' views, the more likely they are to vote. So if you're more confident, you're a high informed voter, you are more likely to vote. So that doesn't say anything about where you are on the spectrum, Democratic, Independent, Republican. It simply says more informed, more vote. In other words, black bars here should always be above the gray bars. And in point of fact, they are regardless, okay? So we need the evidence there to support it. It's going to be the dark bars are higher than the gray bars. At each point in the political orientation, high information voters were more likely than low information voters to vote. That's it. That's exactly right. I don't need to go across the orientation. Only low information voters who identify as independents had it. No, that is not the claim. That doesn't say anything to the claim. The closer that low information voters are to the ends of the political orientation, the more likely they were to vote. That's true. It's accurate. But again, it's not relevant to our claim. D, high information voters were more likely to identify as strong Democrats or strong Republicans than low information. May be true or accurate, but again, not relevant to the claim. A is the correct answer. Okay, which choice effectively uses data from the table to complete the example? So we've got to complete the example or statement given. So let's quick check the table, see if we understand what's going on. We've got evaluation of the likelihood that robots can work effectively in different occupations. So we've got different occupations, somewhat, neutral, or very likely. Okay. So unlikely to likely spectrum, and then the different occupations. So what does the story say? It says as a firefighter, very unlikely robots can work effectively. And surgeons, very unlikely that they can work effectively. And their numbers for very likely are subsequently lower as well. Whereas teacher, television news anchor, tour guide, well, tour guide goes from very unlikely to very likely, okay? News anchor goes from very unlikely to very likely, okay? So we have a couple different extremes. Tour guide, news anchors at the extremes, teachers maybe in the middle, and firefighters, surgeons at the other extreme, not to be replaced by robots. So Georgia Tech roboticists, along with ethicists such and such, were interested in people's perceptions of robots' competence. They recruited participants and asked them how likely they think it is that a robot could do the work required in various occupations. Participants' evaluations varied widely depending on which occupation was being considered. For example, so what we need to show is that they varied widely in their results, and we do. From, again, the extremes are surgeon, firefighter, to tour guide, television news at the other extreme. So let's take a look. 47% of participants believe that it is somewhat or very likely that a robot could work effectively as a teacher, but 30%. Now, that was our neutral case. That doesn't show widely varying extremes. 9% of participants were neutral about it, which is the same percentage. Okay, we don't care about neutral. We want the extremes from likely to unlikely. 82% of participants believe that it's somewhat likely a robot could work effectively as a tour guide, but only 16% believe it is somewhat or very unlikely that a robot could work as a surgeon. That shows an extreme range, right? Depending on which occupation. So here are two examples, at least. It's better than the other answers so far. Let's check D. 62% of participants believe that it's somewhat or very unlikely that a robot could work effectively. Okay, just a firefighter by itself doesn't answer our claim. We need to show widely, which means we need to show contrast, which means we need at least two examples. So C has to be the right answer here. It has two answers. It shows that they varied widely. Okay, another command of evidence, quantitative with a graph. We want to support the researcher's conclusion. I like to take a quick look at the graph beforehand. As always, we're going to find the answer that's accurate to the graph, but also supports or is relevant to the claim that we need. So we need both for the right answer. That's what we always do on these problems. So the first step is I like to understand the graph. If I understand it, I'm probably going to be able to do pretty well in the question. If not, I tend to run into a little trouble. So we need yield, that is pounds per acre from cantaloupes. Okay, I kind of get that over different years, and I've got a control in nitrogen. So we're probably going to test the efficacy of fertilizer here somehow. Let's read. To test the effects of a nitrogen fertilizer on cantaloupe, researchers grew cantaloupe plants and harvested their fruit over 3 years. In each year, half the plants were grown using a nitrogen fertilizer. So half had nitrogen, the dark bars, and they all had a better yield. And the other half were grown using a controller that contained no nitrogen. The researchers concluded nitrogen increases cantaloupe yield. That is true because the dark bars are above the gray bars. It's that simple. In every year of the experiment, plants treated with nitrogen had a yield of at least 30 pounds. No, it's not a set level that it was above. That's not the key idea. It's that it was more than the gray bar, the control. In every year, the experiments treated with nitrogen had a greater yield than did the plants in the control group. That's it. That's what I need to know. B is the answer. In 2018 was greater than 2019. No, it's not a comparison across years. That's not going to help. The yield for plants treated increased from 2000. Okay, any 1 year does not help. The fact that a nitrogen fertilizer plant jumped from 2017 to 18 basically doesn't tell us much of anything. It just could have been a much better year. In fact, the gray even jumped up in that year too. So that's not helpful. B is the answer. Okay, which choice most effectively uses data from the table to complete the text? So here we have to complete the text. We've got some example or statement here at the end, and we're going to need something that shows that's true. Okay. So I'm going to peek at the table as always to figure out what's going on, and then I'm going to go back and find the answer that's both accurate and relevant for this particular question. Okay. So we've got 5 responses to survey about actions to conserve energy. So we've got different actions you can take to save energy, and I guess they've got different categories: efficiency, curtailment, or efficiency. So one of two things. And the percentage of respondents selecting that action. So people said curtailment, they expect a lot more basic results, and that was things like using a bike, turning off lights, as opposed to efficient light bulbs or efficient cars like hybrids, things like that. Okay, so let's read what's going on. In a survey of public perceptions of energy use, researcher such and such asked respondents to name the most effective action ordinary people can take to conserve energy. And of course, what they wanted to do was curtail, right? That seemed to be, was most effective, not just efficiency steps. The team categorized each action as either an efficiency or a curtailment, found that respondents tended to name curtailments more often. That's shown by the table, right? For example, 19.6% of respondents stated the most effective way to conserve energy is to turn off the lights. That's right there. While only, we might say, on the other extreme, 2.8% of people chose hybrids, or possibly 3.6% chose efficient light bulbs. I'm probably going to look for these as my contrasting cases in the answers. That would be my predicted answer to look for. 6.3% said it was most effective to use. That's actually inaccurate according to the text. I think the hybrids said 2.8. Thermostat setting was 6.3. So that's not accurate to the table. 2.8 of respondents said it was most effective to change the thermostat setting. That's inaccurate too. I believe it was 2.8% who said hybrids. Yep. 12.9% said it was most effective to use. No, that's not it, because that was another large group. 3.6 efficient light bulbs. That's it. That's the other extreme of the 19.6, 3.6. Okay, it was one of those two, and we got the efficient light bulbs. This is the answer. That's correct.